What's up guys, welcome back to the channel. So in our last log, we covered chapter 3 of this book right here, which is the Docker deep dive. In today's log, we're going to be diving into chapter 4 and 5. Chapter 4 introduced us to some high-level concept around Docker images and container, while chapter 5 started pulling back the curtain on what Docker really is. Now, funny enough, right at the beginning of chapter 5, the book says you can use Docker without knowing everything in chapter 5. But to master Docker, you should read the chapter, meaning chapter 5. And honestly, I couldn't agree more, because if you want to master something, you have to understand what's going on under the hood. So before I even touched on chapter 4 and 5, I actually hit pause on the book and went down the container rabbit hole, because I really wanted to understand what containers actually are, independent of Docker. Because let's be real here for a second, finding like a really good information that separates containers from Docker isn't easy. So I had to go deep dive to try to separate the two and really get a good understanding of what containers are before trying to understand what Docker actually is. So chapters are listed below as always. Please feel free to jump to whatever part interests you the most. With that being said, let's go ahead. Let's get started. Okay, so before we get started, let's first try to completely detach containers from Docker for a second, well, at least for this first few minutes of the video, because people tend to, especially newcomers or someone that's new to trying to understand what Docker and containers are, we tend to like treat them as if they are one thing, but the reality is they're actually not. So think of it like this. Let's say you're on a Linux server and you launch something like, let's say, VS Code. That action starts a process, a program that gets loaded into memory and is being executed by the CPU. At its core, a container is just a process, but it's a process with fences. So basically rules enforced by the Linux kernel that isolated from the rest of the system. So what makes a container different from just any other process? Well, let's go ahead and talk about them. But before we talk about them, just I had to do a lot of reading to try to get to understand all this concept. So if I do mispronounce some of them, it's a combination of my accent, and I don't want the Linux gurus to come at me. If I do mispronounce some of them, just kind of comment down below and correct me. I'm not opposed to correction. I welcome all corrections, so please feel free to kind of correct me if I mispronounce any of them. So first on the list is the namespace. The namespace isolates the process view of the system, and then you have the C groups. The C groups kind of limit and control resource usage. See, the accent is kicking in. The C groups just does limit and control resource usage. So things like CPUs, memories, etc. And then you have the chroot or mount namespace, which kind of restrict what part of the file system the container can see. Then you have capabilities which drop unnecessary root privileges inside the container. Then you have seccomp, which kind of filter or block dangerous system calls. And then you have union fs, which from my understanding of it is optional, which is kind of like a layered file system support. So when you put all of these together and you get an isolated lightweight process that can still run child processes, aka the apps you install inside it, that's what a container is, an isolated Linux process built using native kernel features. And the wild part is Linux already has all of this built in. The container tooling like Docker or LXC is just a way to make all the complexity easier to use. So technically, you can create a container directly from Linux. When I was kind of deep diving into this, it makes me realize how much of a juggernaut really Linux is, because Linux is technically the foundation on which all of the future technologies are built upon, like literally the foundation. So at this point, I don't know what you're thinking, but at this point during my deep diving and going down the rabbit hole, I started to think, or I started to wonder, what exactly do tools like Docker or LXC add on top of the container that's already on Linux? Well, both are just wrappers around container features, but they take different approach as to how they do things. Docker is built to run one application per container. It's meant to package and isolate that app. So things like, let's say, Nginx, Postgres, or whatever it is that you have set up in your environment. And it handles all the hard parts for you. So networking, volume, startup, teardown, etc. It basically is laser focused on apps not on full systems. LXC, on the other hand, is trying to be more like a lightweight VM, so you can install Ubuntu in it, you can boot it, you can SSH into it, you can run multiple apps on it, and you can treat it like a full OS. It's great for, let's say, system level use cases. The bottom line and my takeaway from diving into this is that don't treat Docker container like VMs. They're not meant to run an entire OS, but with an LXC container, you can. And yeah, like I said earlier, you could technically create a container manually on Linux, but it's tedious and it's definitely not beginner friendly. And that's why you have tools like Docker and LXC container. And that's one of the reasons why they became very popular, because they make container usage and management very easy and very usable. All right, so rabbit hole is over. I'm out of the rabbit hole now. I had to try to understand really what is a container and all these other components of container before diving into Docker. So now that we have, or now that I have an understanding of what containers are, now that you have an understanding, hopefully you have an understanding of what containers are, it's time for us to shift focus back to the book. All right, so let's go ahead and move on to chapter 4. So chapter 4 gives us like a surface level view of Docker, just enough to get us thinking. So it kind of frames Docker from two perspectives. So the first perspective is the ops perspective. This is all about managing Docker, installing it, pulling images, starting container, and checking logs and all this other good stuff. And then there's the dev perspective. And from this side, you are more focused on writing Docker files, cloning repos, building images, and spinning up apps. It also introduced the idea of images. They're basically snapshots of a complete app environment, including all its dependency. But I don't want to create hands-on video for this chapter, mainly because it felt more like a preview of what's coming later in the book. So we're going to hold off on doing anything practical with this chapter and just keep the key takeaway in mind, which is Docker can be approached from two perspectives, which is the dev and the ops perspective, and it'll be wearing both hats as we move forward. Next up is chapter 5. Now, this chapter is where it starts to get good. Chapter 5 starts breaking down what Docker engine actually is. This is the part of Docker that's running in the background managing containers. So before we dive into what the Docker engine is, let's rewind a bit first, because the book touched on a couple of little things that I want us to get an understanding of first before we start breaking apart the Docker engine and getting a better understanding of things. So when Docker first launched, it had two key components. Number one was the Docker daemon. This was kind of the brain that exposed the API and did all of the heavy lifting at that particular time, and it was also using LXC, which was being used to act as the backend that actually created the container by talking to the Linux kernel. However, eventually Docker moved away from LXC and built its own runtime system using a component called libcontainer. This gave them more control and cross-platform flexibility. This shift allowed Docker to evolve into what we have now, which is basically a multi-part engine made up of the CLI, the Docker daemon, something called containerd, and then you have shim, and then you have runc, and then of course you have container. We're going to break down each of those components because those components are basically what makes up the Docker engine. So let's go ahead and take a look at those components. First, you have the Docker CLI. This is a command line tool you use to type stuff like Docker run. It basically sends your request to the Docker daemon. This is not necessarily part of the Docker engine, but it is basically where everything starts, because this is where you type stuff to send the information over to the Docker engine. Next, you have the Docker daemon. This is basically where the Docker engine starts. It's basically an API server that receives your command, so the command that you input from the Docker CLI, and then it basically just coordinates what to do next. It doesn't manage container directly anymore. It used to, like I said earlier, but it doesn't do that anymore. It just basically delegates now. Then you have something called containerd. This is the lifecycle management. It handles container states like start, stop, restart, and all the other good stuff. So it basically pulls image, manage storage. It's basically the container babysitter, for lack of a better word. Next, you have shim. So Shim, I think that's how it's pronounced. Shim's job basically starts after the container is launched, so it keeps the container process alive even if container D crashes. It also handles input and output streams as well. And then you have the main player, the main guy, which is RunC or RUNC, but I think it's pronounced RunC. This is the actual runtime that talks to the Linux kernel and starts the container. It follows what is called the OCI runtime specs, which basically defines how a container should be run. Once RunC or RUNC creates the container, it hands control over to Shim, which then babysits the running processes. Okay, so let's talk a little bit about OCI. The book did mention it a little bit, and I think it's very important to kind of understand this concept. So OCI stands for Open Container Initiative. It is a set of rules that says, here's how you define and run a container. And because of the standards, tools like Docker, Kubernetes, and Podman can all run containers the same exact way using a runtime like RunC. This is basically what makes containers portable and consistent. So whether you're running them on Docker desktop or anywhere else, they are always going to act the exact same way. All right, so that's pretty much it for chapter 4 and chapter 5. Now, I don't know about you guys, but this chapter was a game changer for me to be able to wrap my head around things. So many Docker tutorials treat Docker and container like they are the exact same things. And it's just kind of it was throwing me off, right? And that was like the one thing that was seriously just tripping me, because it's like, what's Docker, what's container? Like kind of like having that separation between the two was very important for me. So taking the time to pull them apart and dive a little bit deeper into what containers are and what Docker is, because the book did a really good job at explaining what containers, what Docker is, but kind of not so much as to what containers are. So me diving a little bit deeper to understand what containers are really helped me out a lot. So I hope this has helped you out too, because chapter 5 is where we start really understanding what's going on behind the scenes, right? So it was very helpful for me, and I kind of really appreciate it. So that's pretty much it. Chapter 4 and chapter 5 in the books. We're getting into the good stuff now. It seems as if we're really starting to get into the nitty-gritty, and I'm really hyped to keep going. As always, stay geeking, stay curious, and I'll catch you guys on the next one. Peace.